Hi, my name is Dmitry Kornilov. I'm from Oracle. I'm going to talk about configurations for Java EE and the cloud. This is a copy of this presentation I presented on JavaOne on 26th of September 2016. This is mainly for people who is interested in this topic but could not attend my session. Uh, this is the legal stuff, and it basically says that what I will talk about may change in future and may not be included in the final product. And here is the agenda. I will start with a short introduction with a little bit of history. And I'll continue with a problem definition. So I'll talk about what kind of configuration problems users are facing now, which can be potentially solved with the JSR we are proposing. Next, I'm going to talk about the JSR itself, about the proposal, about the proposed features, timelines, and explain proposed features in details. And at the end, I prepared a small sample application, sample slides. This is not actually a demo which I can run. It's just a sample application, sample slides to example to better understand the proposed features. In JavaOne, we had a short Q&A session. Now it's not been recorded. So let's start with a little bit of history. My list starts at 2003, but it should have been actually started from the first Java release back in '96. That time, properties class was introduced, the first and the only standard way for working with configuration in Java, even now. The first attempt to implement a functionality we would like to standardize was done in 2003 in Apache Commons configuration project. It supports typed access to configuration parameters and can read configuration from different sources. Another key date is 2009, when Spring 3 was released. This release introduced configuration and code approach, where configuration is coded by special annotations and can be injected to other classes using Spring dependency injection. In 2011, the first version of Delta Spike was released. It has a configuration module. There the ideas of externalized configuration and multiple configuration sources were implemented. It also has a nice SPI-based mechanism of attaching new configuration sources. These days started some attempts of making Java EE configuration standard. In 2013, Mike Cave presented his proposal on JavaOne. He collected many user requests and came out with ideas about what should be included in the standard. Next year, in 2014, Oracle introduced a survey. There were questions about what technologies users want to see in Java EE8. You see the results on screen. Java EE configuration collected many votes. It was not the first one. First was JSON-B, but third place out of 6 shows that users think that it's important. The same year, Netflix Archeos was introduced. It's a configuration framework for the cloud. It has dynamic configuration feature allowing application to work with mutable configuration without restarting the instances. It's also integrated with Apache Commons configuration. Netflix successfully uses this framework in their products. In 2015, Anatol Tresh and Laird Nelson were working on a previous JSR proposal. It was rejected for some reason, but it gave a birth to Apache Tamaya, a modern and feature-rich configuration framework. It's one of the inspirations for my proposal. Of course, Wave and R, many other frameworks trying to solve configuration problems or making simpler. I mentioned only these because later in my talk I'll be referencing them, saying something like, this feature is inspired by Tamaya or Spring Framework or whatever. Now some fresh statistics. I was talking about the Java EE8 survey from 2014, but there was another Java EE survey, joint efforts of dzone and Java EE Guardians. The results were published last week, so it's very fresh. There was a question, how important is to enable dynamic configuration in Java EE applications? This is about dynamic configuration, but not exactly what we are talking about, but it also related, so it makes sense. And the results are here. So 31.7% of users think that it's very important, and only 10.4% think it's not important at all. So it indicates that people still think that configuration is an important task. Now let's talk about what kind of configuration-related problems users are facing. I was talking to many people and found out that there is no common understanding what configuration is. One understanding of application configuration is a server setup for a given environment in means of virtualization, installation, clustering, and so on. Some set of people understand configuration as runtime parameters, such as VM memory and locale. Another understanding is deployment descriptors. That makes sense. Parameters of used frameworks. So it's JPA persistence XML or CDI beans or web XML or whatever. So basically what other configuration of other frameworks used in your application. Resources such as data sources and message queues. It also makes sense. And sometimes people think that configuration is a set of scripts used to deploy the application, sort of a scripting facility. I'm not saying that we are sticking with these definitions. This is what people think. I will give a definition for what we think configuration is later on when I talk about the JSR proposal. Now let's talk about configuration-related problems people are facing now. And first of all, there are some frameworks around which help solving the configuration use cases. For example, Spring configuration, Apache Delta Spike, or Tamaya, and I mentioned them before. The point is that all of these frameworks are using different APIs to achieve the same goals. So there are technologies to standardize, and the first problem is the lack of standard API. Another problem is configuring many instances of the same application in one go. It's a very common use case now that application has many instances in the cloud. There can be some configurable properties such as login level or timeouts, which we need to set for all the instances. And the current model with configuration files inside the application package doesn't work here. Third problem, and maybe this is the most requested use case, is deploy an application on different environments. Dev to test, test to prod, you know what I'm talking about. Currently, to deploy application on the new environment, its package has to be modified to embed their configuration of this environment. And users would like to avoid it. Users would like to take the package and just move it to another environment without any repackaging. This is the dynamic configuration use case. Currently, to change configuration, we need to update application package and redeploy the application. For some properties, it makes sense. For some, it doesn't. Application can handle the change of config property itself. if it's designed the right way and a proper framework is used. And the last problem is configuring a bunch of microservices. Nowadays, applications are not monoliths, but a set of microservices. And often there are properties related to a whole application or to a group of microservices serving one business need. Cracking into each instance package and change configuration there is inconvenient. So here it comes the proposal, which will introduce solutions for all these use cases. So now it's time to define what we mean on configuration. And first of all, we are talking about application configuration, not runtime configuration, not about server or cluster, not about deployment descriptors or scripts, configuration of the application including resources. The configuration is not modifiable by the application. It can be modified by the environment though, but the application can only read it. Configuration is a set of key value pairs, the map, where keys and values are strings. And the structure of configuration is flat, so it's not a tree. A standard we are proposing is called Java EE configuration, and it includes the following features. Unified Java API. I don't think I need to describe what is it, it's clear. Externalized configuration. It means decoupling application configuration and application code, moving config out of the application package. This feature solves the most of use cases I was talking about. Application doesn't care where its configuration is stored, it just reads it using the provided API. And this is optional. If someone wants to use the classic model, where configuration files is embedded into your application package, you're welcome, it's not restricted. This feature is supported by all other frameworks I was talking about. Support of multiple configuration sources means that config can be combined, merged from different sources. Part of it can be read from the properties file, another part from the web server, another from the cloud service, and so on. So it's combined together, provided by to your application. We also need to standardize the formats and types of configuration files. We are thinking of supporting properties format, XML, and JSON by default out of the box. These sources I was talking about are ordered, and high layer sources override values of lower layer sources. This is a concept of layering and overrides. Configuration descriptor is a way to define what is configurable in the application and specify some properties, metadata, and defaults. Dynamic configuration is an ability to react on configuration changes. This is a big feature. It includes polling sources, framework, providers, expressions, and contexts. I'll explain what it all means later. And the last feature is integration with other Java EE frameworks in a way that they all also read their configuration using this config framework. We are proposing this JSR to be included in Java EE 8. We are proposing it late. Java EE 8 releases next year. We don't have time to include all proposed features to the first release. So we selected the core features such as API, externalized configuration, layering and overrides, multiple sources for inclusion in Java EE 8. And all other extended features which are more related to the cloud, we are deferring to the next Java EE release. And here is detailed roadmap. Remember the second slide I showed, the legal stuff. So it may not be included in the final product. So it means that this is just a proposed roadmap. It's not the exact. So their times is very, tentative and flexible. So you can't say that you propose to release public draft in April and not release that. This is just a proposal. So we are proposing to submit a JSR request after JavaOne in October, come out with an early draft in January, and public review in April, and a final release in August. So you see, it's very tough. Now let's go through all JSR features in details. And we will start with API. Let's use example first approach. Imagine that we have a property file as it's shown on the top right corner here. It defines three properties A, B, and C. To read properties, we need to create an instance of our configuration engine. It's done using config provider, as is shown here. It has getConfig method, which returns the default configuration engine. Now let's read the first property by calling getProperty method. The string JavaOne is returned. If we read B property, the same way the string 9 is returned. Not a number 9, but a string 9. The third sample shows what happens if we read property which does not exist. In this case, null value is returned. But framework allows to specify the default value in this case, and it's shown by the fourth sample. So in this case, default string is returned. So it's the same as properties work. And the last sample is type safe property reading. In this case, we are providing a type of the property here, and string will be automatically converted to this type. Let's take a look on this mechanism in details. So the idea is to pack the framework with a set of default converters for primitive types, dates, Java time classes, big types, URL, URI, optionals, or whatever else, and give an ability to register custom converters, which can be created by implementing a converter interface, as shown here. So take a look. Here is a converter interface with just one method, convert from string to your type, and here is how you can implement it. Basically, a similar concept is using in JSON-B. To plug in converters to your configuration framework, the custom configuration is used. Here is a builder pattern, and with converters method, where we actually add converter instances. And when it's done, we can use this getProperty method with class for type safe conversion. Configuration sources. I touched it a little bit before. Look at the picture. Application reads configuration from config framework. It doesn't care and doesn't know where physical data is stored. And it can be stored in different locations, in files with different formats. Config frameworks knows how to read it and merges it using rules defined in the standard. The architecture is pluggable. It is possible to create a custom configuration source and change configuration sources at runtime. You see the database here. Where's the cursor? Database here. It's not supported by default, but a custom data source can be created to read properties from the database, and this source can be plugged in as config service to a framework. Configuration sources are ordered. The order is defined by a number, ordinal, which is assigned to each source. Sources with higher ordinal are more important and override values set in sources with a lower ordinal. This picture demonstrates a mechanism of overrides. Imagine that we have four configuration sources showed here. Here. The number, this number, is basically the original. So we have 110, 120, 150, and 200. So we're sorted. And here are four properties, P1, P2, P3, and P4. And the ball in crossing indicates that the property is defined in this config source. So 110 source defines all the properties, and the 120 only two of them. And the green ball indicates what value from which source is returned when we read the property. So you see that if we read property P1, the value is returned from the source with ordinal 200, so the highest possible ordinal. The same as with P2, in this case 120 is the highest order ordinal. So with these two properties is the same. So it's always, we are always returning a value from the source with the highest ordinal. By default, nothing is configured. Config framework uses these sources to read properties. The orange arrow shows the direction. It tries to read config files from meta-inf directory inside the package. After that, from environment properties, and after that, from system variables. This is by default. As you see, the configuration is not externalized by default. This is to keep the consistency with the current model, and there are use cases for that. But everything is customizable. There are 3 ways to customize the sources: runtime parameter, API, and config sources XML file. The first method is using config.source runtime parameter. It can specify a location of the file as it's shown in the first sample. It can be web resource as it's shown in the second sample. The config framework recognizes automatically what kind of resource is used and creates a proper configuration source. The third sample is a list of sources. The ordinals are taken from 200 and below, so the first source in the list has a high importance, high priority. The second approach is using API. Instead of using default configuration, we are using a custom configuration, builder pattern here. And sources can be added as it's shown here using add source methods. And these numbers are actually ordinals. The disadvantage of this approach is that the sources are hard-coded in the application and not externalized. Config sources XML file. It's the third approach and the most flexible one, and I'll explain why. Config sources XML is an XML file with defined format. Format is defined by the spec, which is used to define configuration sources and their parameters. So when starts, config framework looks at this file in meta-inf directory, but the location is customizable, and it can be supplied using config sources parameter, as it's shown here, or using the API with sources method. Externalizing configuration sources file makes sense because you can change it without application restart. If it's polled, we can add sources there, remove sources from there, which adds a lot of flexibility. And here are 2 samples. First just defines 2 sources. One is web source and another one is file source. The second is a little bit more advanced. They're the same sources defined with ordinals. If ordinals are not defined, like on the first sample, the natural order is used. So it means that order is already defined in config sources file. So the first source has a higher ordinal than the second one. And this is one of the advantages of this kind of file, is that you actually can see in one place where all sources are and how it's sorted. And this is the first sample, and here we have a custom third-party config source which reads configuration from a cloud service. So we need to define a class which implements config source interface, and it has to be on the class path. And we define some parameters here. In our case, these are the credentials to the cloud. These parameters are passed to the class constructor then when it's created. So I finished with features planned for Java EE 8. Now I'll talk about features planned for the next Java EE release. Integration with other Java EE frameworks. The idea is to integrate cloud config framework with other standard Java EE frameworks like JPA or Servlet or JAX-RS, the way that they read configuration from the same source as their application and use the advantages of externalized configuration. So web.xml is stored somewhere outside of the package, persistence XML in the cloud storage, and these kind of things. Another proposed feature is configuration descriptor. Did you have a situation when you are working with some library and you know that some its features are configurable, but you don't know how? And this feature can help in this situation. So configuration descriptor itself is a file with defined format, XML file, which describes how configuration is configured. It contains a list of all properties and their metadata and defaults. So take a look at the sample here. There are 4 properties defined, and B has default value and C is immutable. If this application is passed to ops, for example, to deploy on another environment, the engineers can take a look at this file and see what's configurable there. The descriptor is optional. Everything works without it. And it's not an XML schema. I want to highlight it. I mentioned immutable property on the previous slide. So you may ask, what is it? And I had the answer. Immutable property is read only once. After that, its value is cached and not changed even if the config source is defined as changed or other sources added or whatever. So take a look at these two samples. So again, I'm using matrices and balls, different color. I don't know why balls is always used to explain configuration, but it is. So 2 pictures, mutable and immutable. What do we have here? We have 4 sources with different ordinals. So the bottom source has a higher ordinal than at the top, and there is a timeline. And the timeline shows the change in configuration sources. And we are reading only one property. First sample shows if this property is mutable, what's going on. So you see that originally at the moment T1 is defined in 3 sources, and it's been read from the source of a higher ordinal, which is this one by 150. And at the moment T2, 100 source been removed, so configuration changed. But it's still read from 150 source because it has a high ordinal. Timeline 3, another source was added with a higher ordinal, 200. And in this case, the property will be read from this because at that moment it has a highest ordinal. So the same on T4, basically all sources were removed except 121, so property is read there. Immutable use case, the same change in the sources, but it behaves differently. So when it's read first, it's the same as for immutable property. It's read from 150 source, the source with the highest ordinal. And after that, we can change wherever in the sources. The value is not changed, so it's always this value. So their immutable properties actually, if you define a property as immutable, it indicates that if you want to change this property, the application actually has to be restarted. Dynamic configuration. This is actually 4 features. The idea is that configuration can change and application needs to handle this change. Configuration can be changed because someone changed the config file, or property may depend on other property value, or which is changed, or even it can depend on some data passed by the application. So important to say here is that changes are not initiated by the application. They are coming from the outside, from environment. Application cannot change the config, it can only read it. So the first feature is a polling framework. This is similar to what ArchIOS has, the ability to automatically reread config sources. The second feature is an ability to use expressions in property values. Property resolvers is an ability to call a Java method in expressions. And context is the way to pass some data from the application to the config framework and use this data in expressions. It will allow us to use conditional sources. Sounds complicated. Let me demonstrate all of this. And we will start with polling. So the idea is that each config source can be polled for changes. The polling interval is specified, then the config source is plugged into the framework. So if we're using API, it can be done this way. So refresh rate is an additional parameter in with source method, and it has a type of Java time duration. Another option is to specify polling interval in config sources XML file, as it's shown here. There is a special attribute called refresh rate. There is also refresh rate attribute on the sources itself. You see, so config sources file itself can be polled for updates. Another useful feature is using EL-like expressions in property values. Tamaya has a similar feature. Take a look at the sample here. Property foo has an expression in value. This expression means read value from some.other.property. It can be used if we need to configure, for example, a login level for a group of microservices. So we create a group configuration and put a property with desired login level there. But each of microservices can have different name for login property. And this is where property substitution can be used. Two samples below show formulas. So bar is value of foo plus 10, and buzz is value of foo multiplied by bar. Expressions also can be used to activate configuration sources. So look at the sample below. Their source cast underscore iOS properties is enabled only if the value of application property is iOS. Property resolvers allowed to use custom code and expressions. The use case is injecting resources from a cloud, for example. We define a resolver which connects to user's account, gets a resource by name, and returns its value. It can be a connection string or an URL or some cloud service or whatever. To create a property resolver, user needs to create a class implementing property resolver interface and register it in the framework in config sources XML on using API. So here I'm showing how to register it using config sources XML. So this sample shows reading URL of rating service from, for instance, Eureka, if we have such a property resolver. And the sample below demonstrates reading a database connection string from the cloud property, from CastDB property, from a cloud resolver, which is actually defined here. And the last feature, configuration context. ArcGIS has a similar feature, but not exactly the same. Sometimes configuration depends on some variables, such as application type, geographical zone, or profile. These variables are defined in the application, and this feature allows passing variables from the application to the config framework and use them in expressions. And these variables are a part of special class called configuration context. And here is a sample you see with app variable from the previous slide. So the code below creates the context and configuration context and puts this property there, and after that it reads another property using a special method getProperty with context, and this property can, when we read it, it can depend on the context variables defined in the context. For instance, like here, in other configuration, sources can be plugged in, and this property can be redefined there. I will have a sample which demonstrates all of this for better understanding later. Oh, here it is actually. So this is a small sample to demonstrate the configuration framework features. It's based on a client rating application we made to demonstrate how microservices can be used on WebLogic. It can be found on GitHub. Here is a link. This is a small application which consists of 4 microservices: customer service, rating service, blacklist service, and financial records service. The entry point is customer service, and the purpose is it's from banking, to return a list of customers from this database, and for each of them calculate rating using a rating service. And rating service actually first it calls blacklist service to see if a cluster is blacklisted or not, and after that it calls financial records service to get financial records, and this service communicates with some public registries to get the data. After that, it uses some complicated business logic to come out with a number from 0 to 9 and return it back to the customer service. The use case is that customer service is used by different kind of applications, and it returns 100 records for all applications and only 30 if for iOS applications because of the UI limitations. I'm not going to talk about all 4 microservices. I will talk about these 2 because for the others, configuration is very similar. And here we have a request. See, we are calling getCustomers method here, and we actually provide in the application in the URL which is calling the method. So web in our use case need to return 100 records. If iOS here we need to return only 30 records. So in here, how response looks like. So a list of customers and a rating, and for each customer, this kind of URL is called. Customer ID is provided here, rating service, and it returns a number, which is basically used here. Now let's define what configuration is used by these two microservices. First, it's a database connection string, URL of a rating service, number of records returned, remember two use cases different, and the login level. For rating services, very similar, so there are two URLs of the services it uses, and login level. This slide shows how configuration descriptor for these two services looks like. So let's take a look. The database is immutable, so we have it here as immutable. A rating URL, it's potentially mutable, so basically customer service can be designed the way that it can react on the rating service URL changes. So we can define a polled data source, and if URL changes, it reconfigures itself. Records count, number of records returned. I put a default here, which 100. But if iOS application is used, we need to return 30. So I'll show you later how it can be done. And the login level defaulted to info. For a rating service, it's very similar. I forgot about one thing, context property variable. Okay, so this is actually what this record count value depends on. So if the value of this property is iOS, up, then 30 records, other with default. And here how configuration files looks like. I stick into files because it's easier to show them. First of all, we would like to set a login level for a whole application in some global configuration file used by both microservices. So I put these properties in the global.properties file. Each of microservices have their own configuration files. So there is one for client, customer service, and another one for the rating service. And the URL of database is defined here, URL of rating service is defined here, and this one has URLs of the services it uses. And see, it overrides log level here. So basically, there is a global settings, and here is the override. Okay. And there is another configuration file which we are planning to plug in only if iOS application is used. So we just redefine records count to 30 here. And this is how config sources file looks like. So global sources polled to react on changes in login level. Next goes the configuration for the microservice. And the last one, with the highest priority, highest ordinal, is conditional source, which is enabled only if our application property is iOS. And it's actually application is responsible to give the value of this property to configuration context and read records count property using get property of context method. Rating service has a similar configuration. So basically that's it. Okay. I used a model. The configuration is stored in a shared file system or on a web server. But it can be done millions of other ways. There is a lot of flexibility in defining configuration structure, infrastructure. This is a good thing from one point of view, and from another point of view, is a hassle and can become a nightmare for environment administrators. It can be simplified if cloud vendors introduce a cloud service responsible for storing and managing configurations. It will eliminate the problem of defining and managing a config infrastructure. Everything can be placed in this configuration service, and that's it. And it can be plugged to a configuration framework as a custom configuration source. Here are some more ideas. It can be high available and automatically scalable because it's in the cloud. It can be integrated with other cloud services such as security service, uh, uh, cloud registry, whatever else. It can have a nice UI and REST API and some additional features like versioning, history, security. There is already similar, not exactly, but similar solution because it's not a service but a server with similar functionality. It's a Spring config server. But as I said, vendors can come out with a true cloud solutions. Uh, And here are some next steps. I'm not sure that this is really important for this my recording, but there is a survey similar to which was done in 2014. Here is the link. So we participate. Your response is very important for us. Here is the email address where to send technical questions and comments, and here are some JCP related links. And this slide has its list of Java EE related sessions, which has happened after mine. Also, it doesn't make sense for this recording. And as I said at the end, we had a short Q&A session. Some interesting questions were asked there, but it's not recorded and it's out of scope of this recording. So who actually who was with me to the end of the presentations. Thanks a lot. Bye-bye.